and good day, pre-algebra. We have reached the end of Unit 1. The culminating objective is on least common multiple. And it's fitting that we are talking about least common multiple in the same unit as greatest common factor, because the two things are related and oftentimes mistaken for one another. Okay? What is the difference between a factor and a multiple? And I want to ask it in the context of, what are the factors of 12 versus the multiples of 12? Okay? And to give you a hint, notice how I asked you what are the factors of 12 and what are some multiples of 12. There's a very difference there in the word choice. Lexi.
So a factor is like what goes into 12, and a multiple is what you multiply to go into it, and a factor of 12 is like 4 and 3.
Okay, so the factors of 12, 3 and 4 are in there. What else? Camille. 1 and 12. Remember, I like to work in factor pairs, right? Quentin? 2 and 6. Right? Those are the factors of 12. That's it. There are no others. What are some multiples of 12? Blake? Well, 2 times 6, that would be a factor. Right? Factors and multiples, there's only one number that overlaps in both lists here. Only one number that appears in the factor list will also appear in the multiples list. Cade? 12. What? Well, 12 is a multiple of 12, but 2 is not. 1 is not. Colin? 24 is a multiple of 12. Ah, yes. Now, Haley? 48 is a multiple of 12. So is 36. So I want to skip that one. Lexi? 128? 126? 120 is a multiple of 12. That's way over here, right? Yeah. Okay. What comes after 48? What's the next multiple after 48, Mattis? 60, and then what would come next? 72, and then what would come next? 84, and then eventually you get to 120. Why? What's the difference between my word choice here saying the factors versus some multiples? How are those two important differences there? Camille? Exactly. If I asked you to write the multiples of 12, you'd be pretty busy for an awfully long time, right? Because multiples of 12 go on forever and ever and ever. There is no end to them, right? Because our numbers go on forever and ever and ever, right? Factors, there's only a set number. Multiples go on forever. And so the difference is, as Lexi said, for factors, they're numbers that go into a number, whereas multiples are what a number can go into. 12 goes into 24, 36, 48, 60, etc., etc. These numbers go into 12. Okay? So a multiple is, how do we want to define that? Usually I just throw up the definition for you, but I want to see what you have to say for this one. How would you define a multiple? All right. Multiple. Numbers that a given number, which for our example was 12, can go into. Okay? Numbers that a given number, and I'll put it in parentheses 12 down here because that was our example number. So numbers that 12 can go into would be multiples. Okay? What are multiples of 5? 10, 15, 20, 25, 30. What are multiples of 7? 14, 21, 28, 49. Okay? So when we're asking for least common multiple, we're looking for the smallest number that two numbers can both go into. Okay? So let's use 6 and 10. Hold on, let me pause the video for just a second here. So practicing this with 6 and 10, the first method that we're going to learn, kind of like with greatest common factor, was just the listing method, right? Let's just start to list multiples until we find a common one. So with 6, what are the multiples of 6? 4 is not a multiple of 6, nor is it a factor, so that was kind of odd to say. Haley, you're thinking factors now. We want multiples. Remember, multiples are numbers that, in this case, 6 can go into. 12, okay? 6 can go into itself, and 12, and then what would come next? Jeffrey, 18, and then, 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 let's stop there. So part of this is being able to count, right? Knowing your multiplication tables. Because this is essentially 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5. Yep. You're just counting by 6s as you go up. You're listing the multiples. Okay? The other method the other number that we have here is 10. So let's start listing multiples of 10. Jeffrey. 10. Then 68. Now we're just being silly. After 30 comes 40, then 50, and we'll stop at 60 again. Okay? So like greatest common factor, once we list these numbers out, we're looking for the common ones. And I look at my two lists here. What numbers show up in both lists, Haley? 60 shows up in both. So does 30. If I want the least common multiple, which one of those is my answer? Abby, the 30 would be, right? The LCM is 30. And here's the thing about multiples. I mean, I can find common multiples of 6 and 10 forever. 90, 120, 150, 180, 210, 240, etc., etc. But I only want that first one, right? That least one. Okay? Now, what do you suppose? We talked about pros and cons in greatest common factor. What are some pros and cons to the listing method here for least common multiple? What's good about it? What's not so good about it? Why? You might end up counting a lot further than you had to. Like we went up to 60 where we only would have had to gone to 30. Not a big deal, but potentially. Yeah. Kate? Yeah. Someone said that 68 was a multiple of 10, right? If you're actually serious and you started counting, 68, 78, 88, if you get off in your count, it throws you. When we were listing the multiples of 6, I kind of stopped hearing people right around this mark here. Now, luckily, the number that we needed was less than that, so it wouldn't have mattered if you made a mistake beyond this, right? But if you make a mistake in your counting, that can mess you up. Okay? Yeah.
You can go too little.
Well, if you go too little, you just keep extending. But it's that whole point of when do I stop, right? Since factors, there are only a certain number of factors. So once you had them all, then you had them all. With multiples, right? How far do I go? Okay. Kate. Sure. Yeah. I mean, you can miss 30, and yeah, there are things that can go wrong here. Okay. So we have a second method that I'm going to teach you. And it's not using prime factorization. It's actually using the same chart method that we use for greatest common factor. So if you remember how to do that with that grid, we're going to do the same thing here for least common multiple. Lexi? It gives you a common multiple, but if we're looking for the least common multiple, then that wouldn't give you the answer. Right? There is a way to do it with multiplying, and maybe we'll get to that with this grid chart here. But yeah, I mean, if I asked you for just like, okay, if you were doing fractions and your denominators were 6 and 10, and you just had to get a common denominator, you could multiply them to get 60, right? Because there you don't need the least one, you just need a common one. So with fractions, that'd be great. But with the least common multiple, because it's specifically the smallest one, then we wouldn't want to do that. Blake?
So if you have like 66 and 99, would 11 be 11?
That would be a factor, because 11 goes into 66 and into 99. Multiples would be 66 times 1, then 66 times 2, 132, and then 188, 198, right? So multiples get bigger, okay? So using that grid method here, if you need a refresher on how to set it up, it looks like this, right? And we've got our 6 and our 10. What number goes in that top left section there? Abby? Why 2? Because 2 can go into both 6 and 10, right? And then what do we do now? What's our next step here? Jeffrey? Okay, so we get 3 and we get 5, right? Can we go any further? No. Now, how did this method help us with the greatest common factor? What would the greatest common factor be here? Abby? 2. What do we already know the least common multiple is of 6 and 10 based on our previous method? What do we already know the least common multiple is? Wyatt? Can anyone see how we get 30 from using this grid method as the least common multiple? Wyatt?
2 times 3 times 5.
You can use the grid method for both greatest common factor and least common multiple if you know what you're looking for. In greatest common factor, the blue number here would be our answer. And if we had more of them, then we'd multiply them, right? For least common multiple, it's the blue number times whatever you're left with at the end. So the LCM here would be 2 times 3 times 5, which is 30. What's that? Yeah. So if the grid method went well for you for greatest common factor, you can do the same thing for least common multiple, but how you get your answer changes slightly. Let's do 15 and 21. Let's do the grid to start with here. Okay, 15, 21. What number goes in the upper left? Haley? 3. 3 because it goes into both 15 and 21. Right? What goes in our second row here now? Quentin? 15 divided by 3 is 5. And then Colin? 21 divided by 3 is 7. Are we done as far as pulling out factors? Yes. And how do we know that again? Kate? Nothing that goes into 5 and 7. So if we were finding greatest common factor, what would our answer be? Camille? 3. For least common multiple, what's our answer going to be, and how do you find it? Look at the example above. Haley? 105. How'd you get that? Yeah. For least common multiple, it's what you have in blue as well as what you're left with. So 3 times 5 times 7 equals 105, which would be the least common multiple. Okay? If we did the listing method, we would start with 15, and let's rattle off some multiples of 15. I'll get you started. 15, what comes next? 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 105. I heard a lot of no clues. I heard a lot of I don't knows. Okay? If we start listing multiples of 21, I'll get you started. 21, what comes next? What comes next? 63, what comes next? 84, then 105, right? So you can get there with listing too. And if you can add quickly in your head and reliably in your head, it's a method that can work just fine. If you're not that person, if you like the more kind of organized, keep the numbers a little bit smaller. I mean, here the highest we get, 3 times, you can use a calculator for that, right? I mean, probably don't have to, okay? You can do it with the longhand too, but it's a little bit more organized. Yeah.
So, I have a question. Let's say that after you divide your numbers the first time, they can be divided again.
Yes.
So now you have 2 blue numbers.
Yes.
How does that work?
So you'd multiply those together as well as what you have left. Okay. We don't run into that example here. Let's look on the second page and let's find one where that's the case. Let's look at 6 and 24. No, we'll do 66 and 90. No, yes. 66 and 99, because someone mentioned that earlier as well. Okay. As much fun as listing would be here with 66 and 99, ay caramba. Let's start with the grid and see where that gets us here. Okay. What is a number that goes into both 66 and 99? Camille? 11. So there's our first number in blue. And what we're left with, 66 divided by 11 is 6. 99 divided by 11 is 9. So here's the situation that Sophie asked about. There's another number that can go into both 6 and 9 here, which is what? 3. So we're going to make another level to our grid. We're going to put a 3 over in blue. And what are we left with in row 3 here? Jeffrey? 2 and 3. And now we're done because there's no other number that goes into both 2 and 3. So if we were doing greatest common factor, our answer would be 33 because you multiply the numbers in blue and you're good to go. For least common multiple, you're multiplying everything in blue times what you have left. It looks like a sock. It also looks like an L for least common multiple, right? An L for least common multiple. For least common multiple, you multiply in the L, okay? 11 times 3 times 2 times 3. Anyone got that for us? Cole? 198 is the least common multiple. Right? Does it work for 3 numbers? Do you want to do 8, 14, and 16 or 12, 15, and 20? 12, 15, and 20. Anyone still copying that down? You should be copying this down, those. Okay? Folks, just coming back, we're on the second page. We're looking at the grid method for least common multiple. You might remember the grid method from greatest common factor. We can use it for least common multiple also. Okay? And we're just exploring our first one with 3 numbers here. So to make our grid, okay, 12, 15, 20. What number goes into all three? Camille. 2 does not go into all three. Oh, what'd you say? You said 3. That's good. 3 does not go into all of them either.
No, what the heck? You're really lying. It doesn't go into 3.
Haley? 1. There isn't 1, right? Right? So what does that mean? It's a 1. So if we're left with a 12, 15, and 20, does that mean we multiply all of them together like that to get the answer? So this one gets a little bit tricky with 3 numbers here. Okay? This is where we deviate from the plan a little bit. And what I mean by that is that I'm going to rewrite the grid. If my eraser goes away. Nope. It just wants to. There we go. Okay? With 3 numbers. You're looking for any number that goes into at least 2 of them. So when Camille said 2, you'd probably notice I started to pick my pen up and write up on the board, and I said it doesn't go into all 3. She wasn't wrong in starting with 2. Okay? Because 2 does go into 12 and 20. So our next line here is going to be 6. Is the 15 going to change? And the 20 becomes a, okay. Now, what's a number that goes into at least 2 of them, Jeffrey? 3. What does 3 go into? 6 and 15. So what's my next line going to be here? I got to make my next line first. What's my next line going to be here? Dayton? 2, and then 5, and then 10. Okay? Now, what goes into at least 2 of them? Abby? 2 does again. And that brings us to, what's our next line? 1, 5, and 5. Hold on, there's a light at the end. There's light at the end of the tunnel here. I promise you. What number now goes into at least 2 of them, Cade? 5. And what does that leave us with? What is it? 1, 1, 1. So, when you have more than 2 numbers, you can still use this thinking about what goes into at least 2 of them. If you do it correctly, you'll know you're finished because guess what you'll always have down at the bottom? 1, 1, 1. And then your least common multiple, you can still multiply using the L, but really it's just the blue numbers there. But I don't want to confuse with greatest common factor because multiplying by 1 by 1 by 1 it doesn't change here. The LCM would be 2 times 3 times 2 times 5, which equals 60. Okay? This can get a little bit tricky because with greatest common factor, you'd look for numbers that go into all 3 of them. Okay? And you'd multiply the blue. In least common multiple, you're looking for numbers that go into at least 2 of them. And then you keep going until you're down to 1, 1, 1. All right? Questions on this? For tomorrow, I would only like you to do page 15. Okay? You can use the listing method. You can use the grid method, but work must be shown. Must be shown. What must you show? Work must be? Shown must work? Be. Yes. Yes. Okay? All right, Evan. Yes. So for greatest common factor, it would be a 1 here, which means you'd multiply 3 and 8 together. Yeah. Evan brings up a question with 3 and 8 up at the top. Folks, using the grid method for 3 and 8, you'll notice that there is no number that goes into both 3 and 8. So if it's a 1 here, what does that mean your least common multiple is? Your greatest common factor is 1. What's your least common multiple? 24. Okay? 24. All right? With least common multiple, you multiply by what's in blue as well as what is left. Okay? You've always got to have this extender here for least common multiple. Usually, it'll look like an L. But if there's no greatest common factor other than 1, I mean, you could really, if you wanted, if 1 goes into 3, you could write 3 and 8 down below here, showing that you can't do anything, and then there's your L there, right? So it might be best to do that, but always multiplying in the L for least common multiple. Okay, other questions, comments, concerns, complaints, compliments, congratulations, or criticisms? John? On? Carter? Do you have a congratulations?
Great job.
Thanks, Carter. You too. Jeffrey?
Thank you. To inform you about your extended car insurance warranty.
I got 2 of those calls over the weekend. My fault for answering, but yeah, I got it taken care of both times. I was like, I just did this yesterday, and they're like, yeah, it expired already, so I did it again. Okay, cost me $200, but I got it done. So, John. All right, we are derailing. That's all your math, folks.